Okay, so this is a ALEKS topic that's called Designing a Galvanic Cell from a Single Displacement Redox Reaction. So this is a pretty straightforward topic, but I just wanted to run through it pretty quickly to make sure that we're all straight on it. So the first thing that I'm gonna sort of point out is the presence of this nitrate. So this NO3 that I'm seeing on both sides, this is just a spectator ion. It's just a counter ion that's in there to balance out the charges in my solutions, and it really is not going to play any role in the actual redox reactions. So if I wanted to write out my half reactions, I would just write out magnesium solid, so just starting at the left hand side, and I'm going to ignore the coefficients here. We'll talk about that in just a second a little bit more. Goes to magnesium 2+, so I know that this is magnesium 2+, plus 2 electrons because I've got Mg nitrate 2. So this is telling me that the charge on magnesium is 2+. I can look at my periodic table, know it's in group 2 for that charge as well, and then the nitrate has a 1- charge, so that makes sense. Now this is my half reaction. This is an oxidation half reaction, so let's put that in parentheses. Oxidation, don't know how to spell anymore. This would happen at the anode. So this is my reaction that's happening at the anode. And then my iron, so I would have iron 3+, it's a 3, plus 3 electrons is going to iron solid. So again, I'm ignoring these coefficients for now. We'll talk about that in just a second, like I said. But this would just be my basic reduction reaction. So this is my reduction. This is going to happen at the cathode. So remember that reduction happens at the cathode. And these are my relevant half reactions. I'm not worried about the NO3. It's a spectator ion. It's just a counter ion. And now let's talk about what these coefficients, what's the significance of the coefficients. Well, in this half reaction, I've got 2 electrons. In this half reaction, I've got 3 electrons. We need to balance our half reactions. So if I want to balance this, the easiest way would be to multiply this reaction by 3. So if you see my coefficients 3 and 3, and multiply this reaction by 2. So 2 and 2. So then in my balanced chemical equation, there would be 6 electrons being passed back and forth. So in other equations where we have an N value, that N value would equal 6 in this case. It's going to be equal to the number of electrons passed back and forth in the balanced chemical equation. Okay, so now to answer my questions, write a balanced chemical equation for the half reaction that happens at the cathode of this cell. Reduction happens at the cathode. Remember our oil rig. So reduction is gain, so this shows a gaining of electrons. That's going to happen at the cathode. I remember that consonant, val. So this would be my iron 3+ plus 3 electrons goes to iron solid. And you don't need to put in the 2's as the coefficients, just this would represent that reaction. For the half reaction that happens at the anode, that's my magnesium. So magnesium solid goes to magnesium 2+ plus 2 electrons. Of what substance is E1 made of? So that's my electrode, and that is showing that we've got oxidation happening. We're losing electrons, so this would be oxidation. So this is my anode, and this would be reduction. I'm gaining these electrons, right? Gaining these electrons, so losing electrons, gaining electrons. So this would be my cathode. So if this is the reaction that's happening at my anode, then this metal would be magnesium. So that would be my magnesium solid. What substance is E2? That should be my iron solid. I don't know why I put parentheses there, but that's okay. So iron solid. What are the chemical species in solution 1? Well, that should be my anode solution. So I should have Mg2+, and then I'll also have that NO3-. It's a spectator, but it's definitely in there. That's my source of minus ions. And then for S2, that should be the iron 3+ and NO3-. And that's basically it. All of these will be, oh, you can't see that. All of these will be basically the same type of treatment. Really the key is just writing out your relevant half reactions properly, and then you can answer the rest of these questions pretty straightforward. Okay.